In this video, we shall look at how to apply exponential growth to real-life problems. And remember, here we have the equation for exponential growth. The R is the growth rate expressed as a decimal, and T is the time. So here, if you consider the initial principal, P, deposited in an account that pays interest at an annual rate, R, expressed as a decimal, compounded n times a year, the amount A in the account after T years can be modeled by the equation, this equation right here. Okay, so example, if we deposit some money in an account, so P is equals to 2,900, that pays 3.5, so the rate is 3.5, which is the same as 0.035, because we said we want to express it as a decimal. Write a model to represent the situation for the interest compounded monthly and annually. Find the balance after T years. So let's start with monthly. And monthly, we are going to say the amount is going to be given by the principal, which is 2,900, and then we are going to have 1, I'm just using the equation, plus the rate. Remember, this is monthly, so we have the annual rate, which is 0.035. we are going to multiply by divide by 12, and this is going to be 12, because 1 year is 12 months times time, which is in years. And then here I'm told to find the amount or the balance in 5 years. So remember, this is the model, so I can use it for whatever time. So now I'll use for 5 years, so this will give me 2,900, and this is 1 plus 0.035 and we are dividing that by 12. We're going to multiply by 12 and then by 5 instead of T. Now we have 5, and when we put that in the calculator, it's going to give us 3,453, about 0.8. So that will be the balance in 5 years if it is compounded monthly. So what about if we do this annually? If we do this annually, we start with the model. The model is going to be Y, or let me use A for amount. A is equals to, is the same amount, 2,900, and then this is going to be 1 plus, the rate is the same, 0.035, divide by 1, because it is 1 year, and then it's going to be multiplied by 1 T, or just T, because it is per year, because n, remember the n here, let me note it here, so here n is 12, and here n is 1. So important to know that, because that's what I'm substituting into the formula. So to get the amount now, I just need to put the amount 2,900, 1 plus 0.035 3, 5, and then this is raised to 5 because t is 5, and this is going to give me 3, 4, 4, 4.29 cents. And you can see when it's better when it is compounded monthly, which makes sense because it's getting more interest. Okay. In this second example, you have an initial population of 38 buffalo at a stage park, grew by about 7%. Later more to represent the exponential growth. Then find the number of buffaloes in the park after 7 years. So how do we do this? Remember, we are just going to use the same equation from the previous page. So I'm going to use y to represent the amount or how many buffaloes it's going to be. The initial value, which is 38. That's what I started with. And then it's growing by 7%. I need to convert that into a decimal. And then this is raised to t. That's my model. And now I just need to find the number of buffaloes in 7 years. So this is going to be y is equals to 38, 1.07, and I'm going to raise this to power 7, and that's going to give me about 61. So those are the number of buffaloes which are going to be in the park after 7 years. Okay, so let's go to the next one. And here we are given a classic car which is sold at an auction. We are told here a classic car is sold at an auction, and the owner bought the car in 1984, and the value was $11,000, and the value of the car is increasing at 6.9% per year. So write the function that models the value of the car over time. So suppose I use v for the value. The initial value was 11,000, and this car is increasing in value, so it's going to be 1 plus 0.069 t. And I could simplify that. I could simplify that to 11,000 1.069 t. And then in the next question, I'm told the auction was in 2004. What is the approximate value? The auction was in 2004. What was the approximate value at this time? So I need, see, t represents the number of years since then. So I'm going to do 2004 minus 1984, so that I'll know how much time has passed. So that's 20 years. And remember, it is appreciating per year at 6.9%. So now the amount or the value of the car is going to be given by, I just used the model, and then 1.069 raised to power 20, and this is going to be 41,777.92, and that's some decent amount. Okay, now here sometimes the interest can be compounded continuously. If it is being compounded continuously, this is the formula we use. And you can see there is a letter E here, and actually here E represents a number which is called it's a mathematical constant. And according to Leonhard Euler, the expression 1 plus 1 over n raised to power n approaches E. So E is approximately 2.7. If you have this equation, this expression here, and you start with 1, you keep 1, 2, 3 for the values of n, this is what you're going to get. So this is the formula we are going to use, right? Okay, so here we are told you deposit some money in the bank, and it's going to be compounded continuously. And how are we going to get that amount? So we're going to use the formula. The principal is 3,500, and then this is going to be, the interest is 4%, so 0.04, and you're looking for the amount in 1 year, so we multiply by 1. So using this formula, so we get 3642.84 cents. Okay, the next one here, you're told you deposit 48,000. So you're looking for the amount. So you have 48,000. And for this one, I am using the same formula. So E, and just to let you know, there is the E value in the calculator. If you don't have a calculator with the E value, you can just use this number up there. So E, so 0.065, and then we are going to multiply that by 3, and we are going to get 5833.49. So that is how much will be in the bank in 3 years.